So here we have a ramp, and we're going to put a block on the ramp, and you may think that you let go of the block, it's going to slide down the ramp. However, it might not. It might not move if the friction is strong enough to prevent it from sliding down. And then you may ask, oh, well, can we put it on a steeper ramp? Put it on a steeper ramp, will it still stay at rest? Or how steep of a ramp can we put it on so that it can actually the block does not slide down? So that's the goal of this question. How steep can the ramp be so the block does not slide down? There is static friction involved. There's no applied force in this question. So it's just gravity, normal, and applied force. So I'll draw a free body diagram out for that. First I will define my direction vectors. Y and X. So X down the ramp, Y same direction as a normal force. So I'll draw gravity first, which is straight down, and split it up into the perpendicular components. Okay, then we will have a normal force. This is going to be balanced out with FGY. And now we need this block to stay at rest, so we need friction to balance out with the X component of gravity. So I'll use a single tick mark for the Y components, showing they're equal, and I'll use a double tick mark for the X components, showing they are equal. So there's two equations here, one in each direction. So in the Y direction, we have that the normal force is equal in magnitude to the Y component of gravity. This matters in this question. We're going to need to use this a little bit later. But the other equation, which is in the X direction, we have that the force of friction, the magnitude of it, will have to equal to the X component of gravity to balance it out. Okay, two equations, they're both going to be in use. There's no Newton's second law here because everything's at rest, there's nothing accelerating. So how does this work? What am I supposed to solve for? I'm supposed to solve for an angle. I need to find the angle of the ramp. I don't see any theta in any of these equations. Where is the theta coming from? Well, it actually comes from the formulas for the components of gravity. The Y component of gravity is mg cos theta, whereas the X component of gravity is mg sine theta. Okay, so now at least I have thetas in my equations, so I can get a better sense of perhaps how to solve for theta. What else can we do? Well, we know the formula for the force of friction, so I can continue on and replace the force of friction with mu times normal. That is the formula for the force of friction. So I'll do that step. And now what we have is two equations with two unknowns. That is the key thing to understand about this. We have two equations and two unknowns. Both equations have theta in it. That's one unknown. Both equations have normal force in it, which is unknown. But everything else is known. Well, not really. The mass is not known. But what ends up happening is mass is going to get canceled out. So here, let me show you how that works. I I guess I'll number these. I'll call this equation 1. I'll call this equation 2. And what I'm going to do is I'm going to substitute equation 1 into equation 2. Because equation 1 is isolated for normal force, and I see normal force in equation 2. So I'm going to replace the normal force in equation 2 with the expression from equation 1. So it becomes mu times mg cos theta, so that's the expression I'm substituting for the normal force. And the right side of the equation, I keep the same, no changes there. So that is a key step, a substitution step. All right, now I need to solve for theta here. The trick to this one is, first of all, divide both sides by mass. That'll cancel out the m's. Similarly, divide both sides by g. That'll cancel out the g's. So here, let me rewrite this a bit more cleaned up. So what I have left is mu times cosine of theta equals sine of theta. And I have to solve for theta. So I'm going to need to get the thetas onto the same side. And when I get the thetas onto the same side. And the way I'll do that is to actually divide both sides by cosine of theta. Divide both sides by cosine of theta. That's a little trick, because what happens is on the left side you're just left with mu. And on the right side, what is sine of theta divided by cosine of theta? It is tangent of theta. There's a trigonometric identity there. And at this point, I can solve for theta by doing the inverse tangent. So it'll be the inverse tangent of mu. So it's the inverse tangent of mu is 0.4 there. And I'll get that in the calculator. That's 22 degrees. So the steepest ramp where the block stays at rest will be 22 degrees.